Hello, in this video, we will talk about GenAI and how it is changing the world, especially the infrastructure part of it, which is about GPU, which has been a game changer, and especially about the network architecture which supports the AI workload. So, here we start. GenAI. It is a form of artificial intelligence which is about generating text, images, or audio or else video also based upon the input which has been given to it. And interesting part is it is generating things, not just predicting one. Some of the example of Gen AI include Chat GPT and we have DALI also, which are pretty much famous in the world. All this is important because of an important asset which has made Gen AI possible and faster, which is GPU. We will also start discussing about this topic. Well, before talking about the foundation model, let's give a brief of what GPU is. GPU is graphic processing unit, and it is one important aspect which has been responsible for the generative AI and faster response that we. So, in order to get the required output, the system has to be trained, and that is where large data sets of information has to be fed foundation model. So when we talk about large data sets, we are talking about text, which may be image or even code also. All this is fed into the foundation model so as to generate the respective task. Foundation model is basically called the neural networks, which has labeled and unlabeled training, which is going on through the system, and then it's generate the tasks. Example of tasks are generating of the text, classifying the images, or even creating code also. And in fact, there are tasks which include translation of languages also. All these are the examples of tasks which are generated by learning via the help of foundation model. Now, as we saw, all these exercise, all these compute is going on. However, there's an underlying infrastructure which is required for all this communication to happen. And for that means we need a server. Now, let's look at the CPU, which is the central processing unit, which provides the processing and on which the foundation model works and provides that respective task from the large data sets. If we are using only CPU, the challenges are because it has got limited number of cores, that means slower speed of processing. And with that speed, the problem that happens is that the AI tasks are further slowing down and the output takes very long time to be generated because CPUs are primarily general purpose devices. Now, if we add GPU in this scenario, in that case, what will happen? Because it has cores which are thousands of numbers and it is very good for parallel processing, which gives it edge in the data intensive operations. And most importantly, it is optimized for deep learning, which includes images and video processing. So, with help of CPU, earlier the work that used to take day or week now be with help of GPU done within hours or maximum day. So that is the benefit we can reap from the GPU, which is optimized for deep learning, AI workloads, and image and video processing. GPU connectivity, InfiniBand, and Rocky. So in this case, we can see there are two servers, that is server 1 and server 2. It may be any server, let's say NVIDIA DGX H100, both of them. So in that case, for GPU to GPU communication, which is inside the server, the technology that is used by NVIDIA is called NVLink, which allows faster communication, low latency, and high performance for this inside communication to happen. However, when we talk about the server to server communication for GPU, there's a different technology which is called InfiniBand, which is used by NVIDIA. There's another one which is called ROCE, which is RDMA over converged Ethernet, basically the same traditional Ethernet that we are using. So generally, NVIDIA is preferring InfiniBand, and Cisco and other vendors go for the ROCE based communication across the GPU. So this is about InfiniBand and Rocky and how GPU to GPU communication is happening inside the server and across the servers. Here is how the network architecture for AI workloads look like. If we look at the upper part of this slide, we can see that there are two layers of switches. So this is the same spine layer and the leaf layer, which is used for providing connectivity to the workload. And below we can see are the workloads. So here the connectivity between the spine and leaf is 400 gig, and from leaf towards the downstream, that is the server also. So we have two servers here, NVIDIA DGX 100, one, and the second, the same server, same model. However, in this case, generally what happens in the traditional architecture, we have two NICs which are only uplinking to the 2xs layer or the leaf switches. However, what we can see here is there are total of 8 GPUs in each server. Each GPU mapped to one NIC, and each NIC is uplinked to a different leaf switch, which is called the rail optimized setup. The benefit is that it becomes non-blocking, non-oversubscribed, and rail optimized design. So let us say we want another server workload to be added. So in the same way, another server is added, and then NICs are uplinked to each of the leaf switch, and everything is not converged into one switch itself. That is the benefit, that GPU to GPU communication inside via the NVLink and across the servers will be lossless, non-oversubscribed, and rail optimized. Up to 32 servers can be connected in this type of fashion of the spine leaf. Key considerations for power, cabling, and racks when we are talking about AI workloads. So in the column B, we can see the traditional infrastructure in the data center, which are using ACI, that is spine leaf architecture, and the column C, which is talking about the spine leaf architecture for AI infrastructure. Now, power per rack is somewhere around 10 kilowatt required for each rack, and multiple servers can be stationed. However, because GPUs have been induced or rather introduced in the system, hence the power requirement at least becomes 4 times. So per rack, you require 40 kilowatts or more than that in order to support the high bandwidth or high power requirement by the GPU in that server. Next is the cabling, which is the passive infrastructure. Generally, in the traditional infrastructure of spine leaf, we have top of the rack switches on each rack, and they are up to maximum 100 gig. However, in case of AI infrastructure, the top of the rack switch do not specifically have to be on each rack, and in fact, inter-rack cabling will increase. In addition to that, generally 100 or in fact 400 gig of uplinks are what required as opposed to 100 gig which was in the traditional infrastructure. So in short, complex cabling and the connectivity also is added overhead. Fiber type, for traditional infrastructure, multimode fiber is preferred. However, in case of AI infrastructure, multi-mode, and more importantly, and generally, it is a single mode fiber which is used, which can give bandwidth up to 400 Gbps per day. So this is all about GPUs, Gen AI, and most importantly about the network architecture or infrastructure requirement for the AI workloads. Hope you like it. Thank you.